Hello, this is Melissa. I'm working on question number 4 of test number 1. Here we have a ring slash disc. It's pretty much just a disc with a circle in it, and it goes from bounds r/2 to r, which we will use later. And we're working on finding the electric field at any observation location on the z-axis. Elsewise, it's 0, 0. So first we have to find dq, which is the partial, the changing charge based on the thickness of this ring, the infinitesimal thickness. So first we go and we know that it's a charge per unit area. So we will have a charge over the area of one ring, but in here we have like a disc with a hole in it, so it's pi big R squared minus R squared over 4. And this comes out to 4q over 3 pi R squared. Now we then take this and we multiply it by our dA, so our change in area, which that ends up being 2 pi r, little r, dr. And this is because when you look at it, you have, if you're looking at one thing, the length of one slice is dr, so it would be pi r dr plus, which, because you have to add on whatever was before it, so then that is I think it is just it ends up being a dr that the limit goes to 0. Dr squared, sorry. And then there was also another one of these here too, so that's how you get the 2 factor. So then we end up with 8q over 3r squared r dr. So when we use this in here, and the original d equation is right here underneath. 4 pi E naught times dq, and then we know that this is the ring. This is the equation for a ring. And then we go ahead and throw in our part right here for the dq. And that is in the z-hat direction. So now, because we have that infinitesimal piece of charge, or piece of field, now we have to do the integral. So when you're working with that, you go from so you say E equals integral of, we said our bounds were r/2 to r, and then we put anything that is going to remain constant, and it's in dr direction, so the only thing that isn't constant is this r and this r. So everything else can come out for 3 pi E naught r squared, and then we're left with r dr over 3/2 z hat. And then you could go and actually solve this out, so I'll just write that that's constant, and then you just integrate this piece, and there you go.